This is question 4 from tutorial 1 in the LO2 notes, page 14. So in this question, we're given a scenario regarding a train, and we're given information about its brakes and its maximum deceleration. And then we're asked to find out some further information about this particular scenario. So we begin, as we always do, by listing the information we have in the question, which will help us determine which formula to use and how to solve the rest of the problem. So we're told the train has a maximum deceleration of 0.4 meters per second squared. So our value for A is minus 0.4 meters per second squared. Now, where did the minus come from? Well, acceleration is a vector, so it has direction, and when we're decelerating, put a negative in front of it to indicate that our speed will be decreasing. We're told that at the point the brakes are applied, the train has a velocity of 96 kilometers per hour. So that's going to be our initial velocity. And we're told the train is going to come to rest. So V is going to be 0. And we could write that as kilometers per hour, but since we'll be converting to meters per second, we'll write it as meters per second. And as indicated, we're going to be working on these units. I'm going to convert U just now. So if you remember, the conversion factor here is 1,000 meters to 1 kilometer and 1 hour to 3,600 seconds, the same as multiplying by 1,000 divided by 3,600, or simply dividing by 3.6, so 96 divided by 3.6 is going to be 26.667 meters per second to 3 decimal places. Now in part A of the question, we're asked to find the braking distance. So S is our unknown. And if we want to consult a list of linear equations, we find there is one equation we can use which has V, U, A, and S in it. So the three things we know and the one thing we don't. And this formula is V squared is equal to U squared plus 2AS. So we can put in the values we have and solve this to find the value for S, that is the braking distance of the train. So let's put in our information. Well, V is 0 because it comes to rest. U is 26.667 squared. Remember, you can use the exact value in a calculator, but this should be accurate enough to 3 decimal places for this question. Plus 2 times our acceleration, which is negative 0.4, times S, the thing we don't know. So let's multiply out and tidy up a little bit. So 26.667 squared is going to be 711.129. Again, I'm just rounding to 3 decimal places. By all means, use exact calculator values, and that's going to be minus 0.8s. Because 2 times minus 0.4 is minus 0.8. So rearranging, we have 0.8s is equal to 711.129. So S is equal to this 711.129 divided by 0.8. And that's equal to 888.9 meters. All of our values are given to no more actually 1 decimal place. So that's fine. And that's again the answer that we have in the course notes, or just to clear away a bit of a previous problem there. So we can now move on to part B of the question. Part B of the question asks to find the time taken for this deceleration to 0 to occur. So in part B, we have the option of using any of our remaining formula because we actually have 4 things. We have V, U, and A, which we had in the question, and we had S, in which we just found out there as well. So we could use any of the other 3 formulas. But in in many ways, the easiest formula to use here is going to be V equals U plus AT, but either of those would work out. S equals UT plus a half AT squared would be a bit of extra work since T appears in two places in that formula, but it would still work out in the end. But let's not give ourselves that extra job to do. So we can again take the values from what we're given in the question. So we have V is 0, U is 26.667, and we've got plus, and then A here is minus 0.4, and then T, again, the thing we're trying to find out. So without too much effort, we can see that 0.4 T is going to equal to 26.667. So T is equal to 26.667 divided by 0.4. And again, I'm rounding to one decimal place. That comes to 66.7 seconds. So using our formula for velocity, V is equal to U plus AT, we're going to take the values from the question, substitute them in, and solve for T. And that concludes question 4.